Hi everybody. So I'm going to do number 10 from section 2.1. Our goal is to find the x-intercept and the y-intercept without graphing, and then we need to write the coordinates of each. But to find the x-intercept, we let y be 0, and to find the y-intercept, we let our x be 0. Intuitively, just a real quick draw coordinate graph. Here's our x-axis and here's our y-axis. And the question that I'm going to ask is, why is that the case? Why is it that to find the x-intercept, we let our y be 0? Well, if I draw a line, and I recognize that this is the y-intercept, what is the, and I recognize that this is the x-intercept. I was talking about x-intercepts, my apologies. And I recognize that this is the x-intercept. And any time a line that's graphed crosses the x-axis, any of these points will do. What is the y-coordinate on any one of those points? Well, it's some number, which it also could be 0, but comma 0. So that's why for the x-intercept, we let y be 0. And then for the y-intercept, similar idea, any point on the y-axis has an x-coordinate of 0 and then some number. And so that's at least the rationale behind it. So we come over here, and number 10, a couple people said that they tend to not care for fractions, so I'm going to try and pick ones that are a bit more challenging to do, that have the fractions involved, so we see how to deal with them. So I have 2x minus 2/3 is equal to 3 over 4 multiplied by 0 plus 3. Now, 3/4 times 0, we know that's just going to be 0. And 0 plus 3 is just going to be 3. So I have 2x minus 2/3 is equal to 3. Now, there are, because it's an equation, a couple of different ways we can deal with this. We could multiply through by 3. Again, it's because it's an equation. And we would have 6x minus 2 is equal to 6. Or what a lot of people tend to do is add 2/3 to both sides. And so we end up with this 2x is equal to a 3 plus 2/3. Now, again, I've got to get that common denominator. So I put a 1 in the denominator. I'm going to multiply both by 3. And so I end up with this 2x is equal to 9 over 3 plus 2 over 3. So I now have this 2x is equal to 11 over 3. Now, the formal definition of division is really the multiplication by the reciprocal. It's like the formal definition of subtraction is the addition of a negative. We're going to use that idea right here. Instead of dividing by 2, I'm going to multiply by a half. And the reason that I'm doing that is because I've got to play with a fraction over here. And I'd rather work a fraction with a fraction in terms of multiplication. So I have this 1/2, and I put the 1/2 over here. The 2 2's cancel, and I end up with 11 over 6. So my ordered pair to get the x-intercept is 11/6, 0. So it's 11/6, 0. Now, this time I'm going to let my x be 0 to find my y-intercept. So I've got 2 times 0 minus 2/3 is equal to 3 over 4y plus 3. Well, again, that piece is 0. So I have negative 2/3 is equal to 3 over 4y plus 3. Now, I could subtract 3 on both sides, or I could multiply through by 12. The reason it would be 12 is because both 3 and 4 go into 12. Now, I'm going to stick with the process that I did previously. I'm going to subtract 3, and I'm going to subtract 3. So I'm looking at a negative 3 minus 2/3 is equal to 3 over 4y. I need to get a common denominator, so I'm going to multiply top and bottom by 3 after I put a 1 underneath there. So I have negative 9/3 minus 2/3 is equal to 3 over 4y. Well, I'm going to get here negative 11/3. And again, I'm going to use that process where I'm really dividing by 3/4, but that's the same as multiplying by 4 over 3. And so they cancel on this side. And on this side, I get negative 44 over 9. And so my ordered pair is going to be 0, comma, negative 44 over 9. And you can convert that to a mixed number. I prefer improper fractions and reduced if we could. Okay, hopefully that's helpful.